This is video number 2, significant figures. Measurements have a certain degree of significance, and we can't just write values to infinity. Okay, there's actual limits to what our individual instruments can measure. For instance, if I go into the lab and I have a balance that is capable of reading to 0.01, we'd say plus or minus 0.01 grams, then our measurements are going to be something like 6.43 grams, 8.21 grams, and we would say we have 3 significant figures. So there's 3 figures that the balance gave us of significance to the measurement. When I start adding these up, I can't have additional digits coming out, or multiply and divide, whatever I'm doing. Okay, so there we had 3 significant figures. Now the general rule for significant figures are going to be concerned about zeros, because we use zeros both as data and as placeholders. I can tell you I have $200 in the bank. Does that mean if you go and look at my bank statement, it should say exactly $200? No, because I just told you 200. Well, those zeros there are not significant. So if there's no decimal point on the end, and that's going to be the key to significance, is where's the decimal point? If there's no decimal point listed, we're going to assume these zeros are not significant. They're just placeholders. Now, if I told you that I have $200.00 in the bank, then you're expecting the number to look like this. At this point, we have 5 significant figures, because all zeros are going to be present, all trailing zeros are going to be a part of the significant figures if a decimal point is present. Okay? Now, this can get kind of confusing when we go to a number like this. Let's say I have 0.00648 kilograms. So here, I'm telling you that I have zeros being used as placeholders. These zeros are not significant because leading zeros are never significant. So our rules are zeros caught between digits are always significant, leading zeros are never significant, trailing zeros are significant if there's a decimal place. Now if I use scientific notation, everything's significant in the mantissa, okay? So one of the things that you can really use to tell that this is the limit of significant figures here, which would be 3, is the fact that if I do a unit conversion, meaning I convert this to grams, then this decimal is going to move places. As it does, I'm going to go to 6.48 grams. Well, if this had 5 significant figures, or 6, however you would say it, this would have to still have 5 or 6 significant figures. But if I put these zeros out here, you'd say, well, what does that mean? We don't write numbers like that. That's the point. We don't write numbers like that because they're not significant. Everybody see that? They're not significant. We're not going to write them. So those are not a part of it. So this has 3 significant figures. This still has 3 significant figures. So the number of significant figures are going to be the actual values that are determined by the measurements in the lab. We're going to do a lot of labs and we'll see measurements that way, but we'll also have times where we're just working with data. The data points are going to tell us the number of significant figures. If there's leading zeros, they're never significant. If there's trailing zeros, they're only significant if a decimal place is present.